Hiya there, Mr. Sutton here, bringing you the IM3 Honors Chapter 4, Quiz 1 Review Solutions on Solving Quadratic Equations. On this problem, we're trying to solve this quadratic equation specifically by factoring. So to do that, we need to get everything on one side. Let me just add this 35 over to the left side. And at this point, I notice that I've got an a value here of 1. So I can just ask about factors of 35 that add up to 12. So let's see, we have 1 and 35, that's not going to work. 5 and 7 is the only other option, and 5 plus 7 adds up to 12. So I can break this up into x plus 5, x plus 7. Now, using the zero product property, this basically says that if you have two things being multiplied together, and the product is 0, then at least one of those things has to be 0. So to make this first factor 0, x would need to be negative 5. So negative 5 is one possible value of x. And then to make this second parenthesis 0, x would need to be negative 7. So that's the other possible value of x. To solve this equation by factoring, let's start by getting everything on one side. So I'll leave the 6x squared where it is. Let me add the 6x to get it over to the left. And then let me subtract the 252 to get it over there. So now we've got 0 on the other side. And I notice that my a value is not 1, so let me look to see if I can take out a common factor. Well, 6 would work for the first two terms. Does 6 go into 252? Well, 6 goes into 240 40 times, so it would go into 252 42 times. So yeah, let's take out a 6. In fact, I'm just going to, let's see here, divide everything by 6. And now I guess I'll take it out as a common factor. It doesn't really matter because 6 is a constant, so you can divide it by everything by 6, or you can take it out as a factor. Either way, you'll get the answer. So taking it out as a common factor, that leaves us with x squared plus 1x minus 42 inside. And now I have to factor the stuff inside a little bit more. So things that multiply to negative 42 and add up to 1. Well, 1 and 42 doesn't work, neither does 2 and 21. 3 and, let's see, 14, that's not going to work. 4 doesn't go into 42. 6 and 7. Well, if I have negative 6 and positive 7, that adds up to 1. So let me split this up then. Let me bring down that 6. And then I'll split this up into x minus 6, x plus 7. And then zeroing out each parentheses, we get x equals 6 for the first one, and x equals negative 7 for the other one. And this 6 constant out in front, this can never equal 0, so you don't need to come up with a value of x that makes this 0 because nothing is going to do it for 6. To solve this equation by factoring, I need to get everything on one side. Let me add 15 over to the left side. And now if they didn't say solve by factoring, I might go for a quadratic formula on this one, but if I have to do it by factoring, I'm going to use the AC method. So let me multiply 7 and 15 together. That's going to give me 105 for my AC value. Now I need factors of 105 that add up to negative 26. Since this is a positive that they multiply to and they add up to a negative, that means they must both be negative numbers. So let's go through factors of 105. Let's see here. 1 and 105, definitely not going to work. 3, does that go into 105? It does. How many times? I believe it's 35 times, so that's not even close. And 4 doesn't go into it. How about 5? 5 goes into 105 21 times. 5 and 21. Yeah, I can get a 26 out of that. So if I had negative 5 and negative 21, that would add up to negative 26. So at this point, I'm going to split up this negative 26m into minus 5m minus 21m. Now that I've got 4 terms, I'm going to solve this by grouping. So let me take a common factor out of these first 2 terms. All I can do is take out an m in that case. That's going to leave me with 7m minus 5. For these next 2 terms, I can take out a 3, a negative 3 actually, leaving me with 7m minus 5. And now I can take out this 7m minus 5 as one big common factor, and that leaves me with m minus 3 as my other factor. Setting each of these equal to 0 and solving now, if 7m minus 5 equals 0, well, if I add 5 and divide by 7, I get 5/7 for that m value. And if m minus 3 equals 0, adding 3 gives me an m value of positive 3. For this one, I have to solve this problem using whatever method, but probably the easiest one, since I have a perfect square and another number, is just to square root the equation, solve by square rooting. So if I do that, I'm going to end up with k plus 9 on the left side. And when you square root an equation, you always have to have a plus or minus radical, because both of those would solve the equation, even though the square root by itself is positive. So this is going to be plus or minus the square root of 9, so plus or minus 3. And then I have to isolate k, so let me subtract 9 to the other side. That's going to be negative 9 plus or minus 3. Since I can combine negative 9 and 3, I have to do so to get two different answers. So if I do negative 9 minus 3, that's going to be negative 12. And negative 9 plus 3 gives me the other answer of negative 6. To solve this quadratic equation, I noticed that I have a linear term in here, so solving by square rooting is not going to work. I have to get everything on one side and use either factoring or quadratic formula, probably quadratic formula. So let me keep the negative 3x squared where it is. I'll subtract the 8x to get it over there. And then there's still a negative 12 over there as well. All right, so here's the quadratic formula. Well, first I look to see if I can take out common factors before I do that. But it looks like there's no common factors to take out. So now, let me get the quadratic formula. So that's negative b plus or minus the square root of b squared minus 4ac all over 2a. And then plug in things in. So we've got an a value of negative 3, a b value of negative 8, a c value of negative 12. And if you wanted to, you could actually divide everything by negative 1 and make all those positive. But it's up to you. I'm just going to plug them in as they are. So I've got negative 8, because I have a negative b there, plus or minus square root of negative 8 squared, minus 4 times the a value negative 3, times the c value negative 12, all over 2 times the a value negative 3. Simplifying this a little bit further, negative 8 is 8. Negative 8 squared is 64, so we have plus or minus square root of 64 and some more stuff in here. We've got 3 negatives, that comes out negative overall. And 4 times 3 is 12, times another 12 is 144. So this is 64 plus 144, or minus rather, because again we had 3 negatives. And then we have 2 times negative 3 is negative 6. 64 minus 144, that's going to be negative 80. And simplifying that, I can take out an I, and also while I'm at it, I can split up that 80. Now the biggest perfect square that goes into 80 is 16, 16 times 5. So I've got I radical 16 times 5 up there. Square root of 16 is 4, so this is 4I radical 5. And I notice that 8, 4I, and negative 6 can all be reduced by 2. It's all 3 or nothing. So if I do that, I end up with 4 plus or minus 2I radical 5 all over negative 3. And that is as simplified as this is going to get. For this problem, we're trying to find the points of intersection, which is the same as basically solving this system of equations. So to do that, I noticed that y equals 3x squared plus 5x. So that means I can substitute 3x squared plus 5x for the y over in this other equation. So I can just basically write 3x squared plus 5x equals all this quadratic stuff. All right, now that I've done that, I only have x's, so I can solve for x. Since I've got linear terms for x to the first power, that means I'm either going to have to use quadratic formula or factoring here. I can't just solve by square rooting. Either way, I have to move everything over to one side, and I'm going to move everything over to the left side because doing so would let me keep my x squared positive. So let me subtract this 2x squared from the 3x squared. That gives me a 1x squared on the left. And then we have 5x minus this 14x. That'll leave me with a negative 9x. And finally, I have to subtract, or actually add 14 to get it over here. So that's a plus 14. And then we have 0 left on the right. Now this looks like I can factor it. We have an a value of 1 here. So let's see, two things that multiply to 14 and add up to negative 9. Well, 1 and 14 won't do it, but 2 and 7 might if they're both negative. So I can split this up into x minus 2, x minus 7, and then just solve this using the zero product property. I'm zeroing out each of these parentheses. We see that x equals 2 for that first parentheses and 7 for the other one. And now for each of those different x values, I'm going to have to plug them back into one of these equations. Either one will do, but I have to plug them both back in to get y values that go with them, because we need the points of intersection. So you need an x and a y value for both of them. So plugging 2 in, and I think I'll use this first one just because there's fewer things going on. So we've got 3 times 2 squared. That's 3 times 4, which is 12. And then this is 5 times 2, that's 10. 12 plus 10 is going to give me 22. So I have the point 2 comma 22 as one of my two answers. And plugging in 7, I'm going to use the same equation. So we have 3 times 7 squared plus 5 times 7. Well, let's see here. 7 squared, that's going to be 49. 3 times 49. Now, let me just do this on the calculator. There we go. Let's let the calculator crunch those numbers. And that's going to come out to 182. All right. We'll take their word for it. So that means my answer is 7 comma 182 for that point.